So today is the first day of Unit 2. This is factoring expressions. Do me a favor, take your highlighter or the highlighter of somebody in your group, and before you just start highlighting randomly, please listen closely. The numbers I want you to highlight are very specific. Do not just highlight across. I want you to highlight this one, 4, 9, 16, 25, all the way down until you get to 169, and then do the second column, 196, all the way down to 625. These are all examples of perfect squares, and I want these to be memorized. We're going to start with stuff you learned in 8th grade, maybe in 9th grade, and then we're going to work up to new ways to express this expression in a different form. So they're always going to be equivalent to the original, just a different form of it. All right, starting with example 1. It says a squared minus 25. You're doing the same thing with me, showing all of your work. Feel free to move your desk slightly or your chair so you can see the board if you need to. All right, so the number in front of the a is a 1. And I know two numbers specifically that I can multiply to get a 1. That would be 1 and 1. That pen isn't working. That'd be 1 and 1. I know that this square, when I divide it by 2, 2 divided by 2 is 1. So a to the first and a to the first. And 25 breaks into 5 and 5. Now, because it is subtraction, I can rewrite this expression as 1 a to the first in front, 5's in back, 1 is positive, and 1 is negative. If you would FOIL this out and combine like terms, you'd end up with this same expression. This is your answer. Going on to number 2. Moving on to number 2. 49 and 100. Can you find 49 and 100 in the highlighted region? You can. And because it is subtraction, and because this exponent can be divided nicely by 2 and equals a whole number, I can move forward. This breaks into 7 and 7, 10 and 10, b to the first and b to the first. The 7 comes from the front, so it's going to remain in front. 10 comes from the back, it will remain in back, with a b to the first stuck behind it. 1 is positive and 1 is negative. It does not matter which parenthesis contains the plus sign in between the two terms and which one contains the subtraction sign. 9 and 225. Is 9 and 225 also on this list? 256, excuse me, and 9. 256 and 9. They both are. Breaks into 3 and 3. C to the first and C to the first. And 16 and 16. 3 C's stay in front, 16 stays in back, 1 is positive and 1 is negative. 324 and 16, are they both on the list? 324 and 16, okay? This breaks into, 324 breaks into 18 and 18. D squared, the square divided by 2 is a d to the first and d to the first, and 4 and 4. So 18d to the first, 18d to the first, plus and minus a 4 and a 4. Now, here's a way that you are going to prepare. Every single day you are preparing now for your next test, because you know in less than 2 weeks you're taking your next test. And our goal is to maximize your ability. So you're pretending this. Tomorrow, you are taking a checkpoint quiz, but you're pretending tomorrow is an actual test. It's a test. And my question for you is on every single one of these problems, you're going to reevaluate your own ability. If you feel like example 1, you could do example 1, you feel 100% confident you can get it right in a time circumstances. Then you put, don't do it yet, you put a star. If you feel like example 2, I need to review that if I'm going to be tested on it tomorrow, you put a circle. Please do that for examples 1 through 4. Feel no shame in circling all 4. The reason most students struggle with factoring is because they have not learned their times table. Okay? So one thing you can work on at home is memorizing this. Okay, we're going to go down to example number 5. Example number 5. 5 and 20, are they on the highlighted part? Yes or no? No, okay, so now here's what we do when they're not on the highlighted part. I go to the smaller of the two numbers, which happens to be 5. It happens to be 5. I want to zoom in here so it's a little bit easier to see for you guys. And the factors of 5 would be 5 and 1. I start with the largest of the two factors. Does 5 also divide nicely into 20? So I factor out of 5 and put parentheses behind it. I know 5 times 1 is 5. I bring down the subtraction sign. And 5 times 4 is 20 with an f squared behind. Now you want to ask yourself, can you go further? So how do you determine that? Is 1 and 4 in the highlighted list above? Is 1 and 4 in the highlighted region above? Okay. Can you take this square on the f, can you divide it nicely by 2? And do you have subtraction in between? Tells you can go on. Now, what does it become? I know 1 times 1 is 1, 2 times 2 is 4, and f squared, the 2 divided by 2, would be f to the first and f to the first. So that tells me what to do. The 1 comes from the front, it stays in the front. 1's positive and 1's negative, 2f to the first and 2f to the first and back. Now, anytime something has a variable, has an exponent of 1, it's not necessary to put the 1, but you're welcome to put it if you'd like to. After every problem, please put a large circle or star. Star means I don't need to review. I'm 100% positive I can do that and do it quickly tomorrow. I'm going to take this problem and I'm going to rewrite it so that there's, well, let's see what we can do actually first. Let me teach you something else. Let's see what we can do. Okay, is 12 on the list? 12 is not on the list. So let's go with factors of 12. Can everybody grab your calculator and type in 75? Now I'm going to take 75 times the largest factor of 12, which is 12. Take 75 divided by 12. It's not a whole number, so let's try the next factor of 12. 75 divided by 6, that doesn't work. 75 divided by 4, does not work. 75 divided by 3, oh, there it works. So I'm going to factor out a 3, and not only am I going to factor out a 3, let's try a negative 3. Negative 3 times 4 is negative 12, attach the d squared. Negative 3 times negative 25 is a positive 75. Is 4 and 25 on the list to the left? Can I divide this exponent by 2 and get a whole number? And since I have subtraction, I can continue. This is 2 times 2, g to the first and g to the first, and 5 times 5. 2 g's come from the front, they stay in the front. 5's come from the back, they remain in the back. 1's positive and 1's negative. Now, which one you have positive and which one you have negative makes no difference. Okay, go on to example number 7. Example number 7. Is 63 on the list? Please look at the highlighted list. Is 63 there? Okay, so let's go to the smaller of the two numbers. Grab that calculator once again, please. And I'm going to start with going, okay, let's go 63 divided by 28. That's the largest factor of 28. Doesn't work. Let's go 63 divided by 14. That doesn't work. 63 divided by 7. Hey, that works, okay? So I'm going to factor out a 7. 7 times 9 is 63. Attach the h squared. 7 times 4 is 28. Bring down the plus sign. Now, most students would go, okay, 3 times 3 is 9. I divide this by 2 to get h to the first. 2 times 2 is 4. But I know I can't go any further in rewriting this expression because there's a plus sign. Problem is done. Now, example number 8, is 50 on the list? Okay, so let's start with the smaller of the two terms. And I know the largest factor of 18 is 18. So let's go 50 divided by 18. Doesn't divide in nicely. Let's go 50 divided by the next number here would be, let's try 6. That doesn't work. 50 divided by 3. Nope. 50 divided by 2. Okay, so it's 2 is what I'm going to have to factor out. 2 times 25 is 50. Bring down the subtraction sign. 2 times 9 is 18. Bring down the j squared. Can I move forward? Okay, I know 5 times 5 is 25 and 3 times 3 is 9. I know this 2 breaks into j, and I have subtraction, so I can go on. 5's come from the front, they remain in the front. 3 j's come from the back, they remain in back. Now do not flip over your paper. Right now you're going to evaluate yourself on examples 1 through 8, knowing you have a timed checkpoint quiz tomorrow. Every problem should be circled or have a star in it. Do not feel embarrassed to have mostly circles. When you're done, find example number 9. Example number 9. Is 8 on the highlighted list? Is it a perfect square? Yes or no? Okay, what's the largest factor of 8? 8. Can 8 nicely divide into 40? The answer is yeah. So let's factor out an 8. 8 times 1 is 8. Bring down the k squared and the subtraction sign. 8 times 5 is 40. Is 1 a perfect square? Is it highlighted? Yes. Is 5 a perfect square? Is it highlighted? Can't go any further? Box it in. Number 10. Is 392? Is 392 on the list? Yes or no? Is 18 on the list? Nope, it's not. So let's do this together. You ready? I'm going to start with the largest factor of 18, which is 18. 392 divided by 18 does not work. 392 divided by 9 doesn't work. 392 divided by 6 does not work. 392 divided by 3. 392 divided by 2. Okay, we have to divide by 2. Let's factor out a 2. 2 times 196 is 392. Bring down the subtraction sign. 3 times 9 is 18. Bring down the m squared. How do you know if you can keep going? Please check, is 196 and 9 on the highlighted list? Okay. Can I take this exponent of 2 and nicely divide it by 2 and get a whole number? And I have subtraction, so I can keep going. Please look at the list. 196. What is the perfect square of 196? So it's 14 squared. So 14 times 14 is 196. 3 times 3 is 9. When I divide 2, I get m to the first and m to the first. 14 comes from the front, it stays in the front. 1's positive and 1's negative. 3m to the first in the back of both. If you FOIL this out and multiply by 2 and combine like terms, you'd end up with the exact same expression. These are 2 different ways to write the exact same thing. Okay, do me a favor, make sure on 1 through 10 right now, please self-evaluate yourself. Ms. Botello is going to walk around to make sure that you have circles or stars on every problem. Number 11, looks like we need more of a challenge. You guys are starting to get tired, okay? Find 25 and find 4. 25 and 4, are they on the highlighted list? Yes. Can you divide 6 by 2 and get a whole number? And can you divide 10 by 2 and get a whole number? Yes. Okay, so here we go. This is 5 and 5. This is 2 and 2. N to the third and n to the third. P to the fifth and p to the fifth. Because it's subtraction, I can move forward. I have 5n to the third in the front of both. 5n to the third. In the back will be 2p to the fifth. One's positive, one's negative, and we have fully simplified this problem. Okay, let's go on right now to this problem. We are going to do something just a little bit different here. It will make a little more sense to you. Let's rewrite this. Does everybody see how the negative sign is attached to the 9 and the positive is with the 121? Let's just switch the order. Can everybody write down 121 r to the 14th subtract 9q to the 16th? 121 and 9 are both on the list of perfect squares, and 14 and 16 can be divided by 2 to get a whole number. That means this breaks into 11 times 11, 3 times 3, and when I divide by 2, R7, R7, Q8, and Q8. The 11 R to the 7th remain in front, and the 3 Q to the 8ths remain in back. One's positive and one is negative. Find example 13. Is 72 on the list? Please look at the list. Flip to the front. Is 72 on it? 72 is the smaller of the two terms. So grab your calculator, please. I'm going to type in 162, and I'm going to start with the largest factor of 72 and work down until I find one that does divide it nicely. So divide it right now by 72. 72 does not work. I do not receive a whole number. Now divide it by 36. Doesn't work. Divide it by 18. It does work. Okay, so that means I can divide both terms by 18. So put an 18 out front. 18 times 4 is 72. Attach s to the 4th. Okay, 162 divided by 18, I've already forgotten, is 9. Okay, so 18 times 9 is 162. Bring down the subtraction sign and attach the t to the 12th. How do you know, please make sure your phone is on silent, how do you know if you can move forward? So find, is 4 and 9 both on the highlighted list? Can I take 4 and 12 and divide both of them by 2 and get a whole number? Okay, here we go. 4 breaks into 2 and 2, 9 into 3 and 3. S goes into s squared, and t goes into t to the 6th. So 2s squared is in the front of both parentheses. In the back would be a 3t to the 6th. One would be positive and one would be negative. Once again, please look at 1 through 13, making sure every problem has a big circle to identify as I need to review this, or I need to ask individual questions about that problem, or has a star. I'm feeling 100% confident I can do that and do it quickly. Number 14. 81 and 16. 81 and 16, are they on the list? Okay. Can I divide 12 and 20 by 2 and get a whole number? Okay. So 81 is 9 and 9. 16 is 4 and 4. This 12 breaks into 6 and 6, and V breaks into 10 and 10. Okay, here we go. 9u to the 6th, 4v to the 10th, one positive and one negative. Most students believe that this is the correct answer, but it's not done. This particular part of the problem all lies up here. I can't go any further with because there's a plus sign. I can't go any further because this is a plus sign. But everybody look over here. Is 9 and 4 both on the list, highlighted list? Can 6 and 10 be divided by 2? So this part of the problem I can take further because of all of those factors. This breaks into 3 and 3, 2 and 2, and I have u to the 3rd and v to the 5th. So I'm going to write down my final answer here. This portion is 3u to the 3rd, 2v to the 5th, and then I bring down the parenthesis from the original portion that I could not break apart any further. The order you put these 3 parentheses in does not matter. Go on to example number 15. Is 256 on the list? Is 81 on the list? Okay. Is 14 and 27, is 14 and 24, can they be divided by 2 to get a whole number? Okay, you ready? You're going to erase me. I'm going to give you a 10-second head start. Working by yourself, it's okay if you don't get done in time. Ready, begin. Is 256 16? When you look at this problem, if I said to you, can you break it down further? Well, I know this part cannot be broken down any further because it has a plus sign. Please look at your partners, turn to your partners. What is the only part of this problem that prevents us from breaking down this parenthesis? 16 breaks into 4 and 4, and 9 breaks into 3 and 3. 12 can be divided by 2. Can 7 be divided by 2 to get a whole number? It's the only reason why you can't go any further. Done. Only a few problems left. Here we go. Next one up, 2 and 8. 2 and 8 are not part. They are not part of that list of perfect squares, but I do know that 2 divides into 8, so let's take out a 2. We are factoring out a 2. I also can see that when I say groups, I mean on the left and on the right, they both contain a y. Now, how many y's can I evenly take out of both groups? This has 3 and this has 1, so the most I can take out of both would be 1 y. Same concept for z. This has 1 z, this has 3 z's. The most I can take out of both would be 1 z. 2 times 1 is 1. I need 3 y's. I currently have 1, which means I need to attach 2 more. I need 1 z, and I already have it. Bring down the subtraction sign. 2 times 4 is 8. I need 1 y. I already have it. I need 3 z's. I have 1. I need to attach 2 more to equal 3. 1 and 4, are they both on the list of perfect squares? Yes. 2 and 2 is exponents. Can I divide both of them by 2 and get a nice whole number? So my final answer here, 1y to the first is in front, 2z to the first is in back. You're welcome to put a 1 above the z's and the y's. Just know that even if you don't have a 1 like I have in front, without seeing a 1, it implies there's a 1 there as the exponent. Make sure everything on this paper, examples 9 through 16, you've identified with either a large circle or a star to identify whether you need to study it or you feel very confident in factoring that type of problem. 3 problems left. 2 of the 3 are much more difficult than what we've done. When you look at this problem, example 17, what makes it look difficult? Ali, look at this problem. What makes it look difficult? The parentheses, right. Ali, give me any variable that's not up there. Just tell me a variable that's not, tell me a variable other than A and B. C, okay? I'm going to make it even easier. Can we say X? Just make it really easy? Okay. Can everybody go over the top of this and write really lightly, make a big X? So we're going to write 3 with the large X, 3 with a large X, and then it's squared, subtract 12. Now, 3 and 12, are they on the highlighted list? Turn back to the front and see if you don't know. Is 3 and 12 on the highlighted list? Okay, but what can I take out of both? Well, let's start with factors of 3. Does 3 nicely divide into 12? It does. 3 times 1 is 3. Attach the x squared. 3 times 4 is 12. Break down the subtraction sign. Is 1 and 4 on the list? Can 2 nicely be divided by 2 to get a whole number? So this breaks into 1 and 1 and 2 and 2. So 1x and 1x, 2 and 2 with one of them positive and one of them negative. Because 2 squared would break into 2 to the first and 2 to the first. Now the only thing I've left to do is really there wasn't an x. Like Ollie said, what is the confusing part here? What was x equivalent to? A minus b. So I'm going to go through this slowly. I have 3 up front. Then I'm going to do a bracket. I'm going to put down a 1. Now I'm not going to put an x. I'm going to put what x is equivalent to. A minus b plus 2. That's this parenthesis. I'm going to do the last parenthesis. 1, not an x, a minus b, subtract 2. Okay, go to number 18. Okay, this time we have 2 different parentheses. So I'm going to use the variables x for the first one and y for the second. And you need 2 unique variables to represent these expressions, x minus 1 and x plus 2. So this problem is 9x squared minus 16y squared. 9 and 16, can they be found on the list? Can the squares be divided by 2 to give you a whole number? So this answer is 3x in front of both, a 4y in back of both, 1 positive and 1 negative. Now really we didn't have an x. What do we have? What was x equivalent to? A c what? Okay, so I'm going to go through it slowly. 3 times c minus 1 plus 4 times not y but c plus 2. That's my first parenthesis. Then 3 times not x, c minus 1, minus 4 times c plus 2. Okay, you ready? You're going to erase me. Please find example number 19. You get a 10-second head start. Begin.